Hello! Today we're going to take a look at negative exponents, which is something that we haven't seen before. We've dealt pretty extensively with positive exponents, and we've even seen what happens when 0 is an exponent, but we've never had a negative exponent yet, so today we're going to see how to deal with those. When I introduce negative exponents to students, I like to show a pattern to help explain why negative exponents act the way they do. So what we're going to do is we're going to look at 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st, and 2 to the 0. And the goal is to see if we can find a pattern and use it to figure out what 2 to the negative 1st, 2 to the negative 2nd, and 2 to the negative 3rd will be. Let's start at the top. 2 to the 4th is 2 times 2 times 2 times 2. Which is 16. 2 cubed is 2 times 2 times 2, which is 8. 2 squared is 2 times 2, which is 4. 2 to the 1st is just 2, not too difficult, all right? Now, what's happening each time we move down from one exponent to the next, to get from 16 to 8, to get from 8 to 4, to get from 4 to 2. What are we doing each row? We are dividing by 2. And the reason that we're dividing by 2 every time we go down is because we literally have one less factor of 2. We had 4 factors of 2, we had 3 factors of 2, we had 2 factors of 2, we've got 1 factor of 2. And if we continue and go down, we have 0 factors of 2, and 2 divided by 2 gives us 1. So this pattern shows us that 2 to the 0 is 1, and we know that this is consistent with what we saw the other day. Anything to the 0 power is 1, except 0 to the 0, which is undefined. So this matches what we've seen before, which is good, but we can continue to see what the negative exponents are going to be. What happens when we take 1 and divide it by 2? We get 1/2. So 2 to the negative 1st is 1/2. What happens when we take 1/2 and divide it by 2? We get 1/4. What happens when we take 1/4 and divide it by 2? We get 1/8. So we can see here, whenever we have a negative exponent, it doesn't give us a negative answer, it gives us a fractional answer. So negative exponents cause fractions. Aha! This is interesting. We can even be more specific when we're looking at these negative exponents. 2 to the negative 3rd is 1/8, but this denominator 8 is the same as 2 to the 3rd. So effectively, 2 to the negative 3rd is 1 over 2 to the 3rd. We can actually generalize this for a rule. The rule says if we have something to a negative power, a to the negative n, we can move that quantity to the other side of the fraction bar and change the exponent to a positive one. And we put a 1 in the numerator because, well, we can't have a fraction without a numerator, but also a to the negative n is technically, I'm just going to write this off to the side, 1 times a to the negative n. So when that a to the negative n moves to the denominator as a to the n, we're still left with a 1 in the numerator. All right. Now, regardless of all of that, this is the rule that tells us what to do when we have a negative exponent. We take the quantity, we move it across the fraction bar into the denominator, and we make the exponent positive. And once we have a positive exponent, we should know how to deal with it because we've been dealing with positive exponents for a while now. Another part of this rule tells us what to do if we have a negative exponent that's already in the denominator. Well, if that happens, again, we can take that negative exponent and make it positive by moving this to the other side of the fraction bar, which brings it then up into the numerator. And here, I'm not going to put a 1 in the denominator because anything divided by 1 is itself. So the rule is just going to be 1 over a to the negative n equals a to the positive n. Whenever something has a negative exponent, we can change it to a positive exponent by moving it across the fraction bar. That's an important rule. This is how we express the rule in words, and this is how we express the rule algebraically. There is one more rule that we'll see here. If we have an entire fraction that's raised to a negative exponent, because that negative exponent affects both the numerator and denominator, we can change that negative exponent to a positive exponent, but we've got to move both the numerator and the denominator, which causes us to flip the fraction. All right. We're going to look at just a couple quick examples, and then you should look at the other videos so that you can see more examples of worked out problems. All right, let's take a look at 7 to the negative second power. We can make that exponent positive by moving it to the denominator, so this becomes 1 over 7 squared. And we know 7 squared is 49, so this becomes 1/49. We can do the same thing if we've got a variable. If we've got x to the negative fifth power, we can take that negative exponent and change it to a positive by moving it across the fraction bar. And we've got 1 over x to the fifth. Let's look at a couple more examples. Let's take a look at 3y to the negative fourth power. Now, we have a negative exponent here, and we know that we can deal with that. We can make it positive by moving it to the other side of the fraction bar. So that becomes a y to the fourth in the denominator. However, this 3 is not affected by the negative exponent. So that 3 is not going to move in the denominator. It's going to stay up in the numerator. And so we end up with 3 over y to the fourth. Good. And let's do one more example. This one, I want to use a few rules of exponents. So let's take a look at 5x to the negative third squared all over x to the 10th. And suddenly it's complicated. This is fine. We can deal with this. First, let's deal with this exponent that needs to get distributed. When we distribute it, 5 squared is 25. And then x to the negative third squared is x to the negative sixth. We know that we need to multiply those exponents all over x to the 10th. Now we've got this negative exponent. We can make it positive by moving it into the denominator. So that 25 is going to stay in the top. The x to the 10th will stay in the bottom. And then that x to the negative sixth moves to the bottom and becomes x to the sixth. And now we want to combine these two in the bottom. We know we can do that by adding the exponents. So in the end, we get 25 over x to the 16th. And that is our final answer. Whenever we're dealing with simplifying an algebraic expression, we never want to have a negative exponent in our answer. We want to make sure that all the exponents are positive. We don't want any variable written multiple times when they can be combined. And we also don't want grouping symbols when they can be gotten rid of. So in general, that's what we're doing when we are simplifying these expressions.